In a surprising turn of events, NASA's James Webb Space Telescope has made a discovery that has astronomers around the world in awe. A few weeks ago, the telescope discovered the earliest known galaxy in the universe. But now, it has detected something even more massive, a supermassive black hole moving away from its galaxy at an incredible speed of 4 million miles per hour. This latest discovery has very important implications and has generated much speculation among scientists and space enthusiasts about what it means for our understanding of the cosmos. The James Webb Space Telescope was launched on a mission to explore the first stars and galaxies in the universe and has captured stunning images of the death of stars and galaxies from a few 100 million years after the Big Bang. We invite you to join us to explore the latest discoveries from this telescope. Remember to like and subscribe for more content like this one. The latest discovery is challenging the scientific community's current understanding of black holes. Black holes are generally thought of as huge entities that pull everything, including light, toward them. However, the recently discovered black hole appears to be having the opposite effect. Instead of absorbing light, it is creating brand new young stars along a trail. This new trail of newborn stars has been observed in the wake of the black hole and extends to an incredible 200,000 light-years away. Scientists are puzzled by the unusual behavior of this black hole compared to others, but a team led by geoastronomy Professor Biendar recently reported their findings in the astrophysical journal Letters. NASA's Hubble Space Telescope also confirmed these observations, suggesting that the black hole awakens when it comes into contact with new stars, with gas, and cools it. We are seeing the wake behind the black hole, but that's not all. NASA has made an exciting announcement about the galactic merger ARP-220, which was captured by the James Webb Space Telescope. This impressive galaxy merger is visible shining among other galaxies in the night sky. When two spiral galaxies merge, the phenomenon known as ARP-220 shines brightest in the infrared, making it perfect for observation by the James Webb Space Telescope. It is classified as an ultraluminous infrared galaxy with a luminosity of 1 trillion suns, compared to our own galaxy, the Milky Way, which has a much lower luminosity of about 10 billion suns. ARP-220 is located in the constellation of Serpens, about 250 million light-years away. It is regarded as the brightest of the 3 closest galactic collisions to Earth and is listed as object number 220 in the Atlas of Peculiar Galaxies. About 700 million years ago, 2 spiral galaxies collided and triggered a huge explosion of star formation. This created a dense region about 5,000 light-years across that contains about 200 large star clusters. Surprisingly, this small area contains more gas than the whole Milky Way. Previous observations with radio telescopes discovered about 100 supernova remnants in less than 500 light-years across. Then the Hubble Space Telescope revealed that the parental galaxies are located 1,200 light-years apart and that each core contains a rotating ring of star formation that emits dazzling infrared light. The latest views from the James Webb Space Telescope show an impressive galactic merger of the 2 galaxies. This image also shows faint tidal tails extending from the area around the merger, indicating the gravitational pull. Finally, the red space between the 2 galaxies, ochre and orange streams, and filaments represent scattered organic materials in ARP-220. Another stunning discovery stumped scientists when researchers found primordial galaxies at the edge of the universe. They were skeptical regarding their veracity, some thought they might be nearby galaxies in disguise. So, they shared the data with other scientists around the world, hoping for the best. Amazingly, the James Webb Space Telescope confirmed that these ancient galaxies are real. Thanks to this revolutionary telescope, we can now observe the oldest galaxies ever seen. Astronomers estimate that light from these galaxies has traveled more than 13.5 billion years to reach Earth, giving us a glimpse into the distant past of the universe. These galaxies were discovered when the universe was young, which sheds light on how quickly the first generations of galaxies emerged. The spectral data confirmed that these galaxies are at the edge of our view, some even farther away than Hubble could see. This discovery is crucial because it validates one of the most important tasks of the James Webb Space Telescope, to study the early universe through light that has been traveling for more than 13.5 billion years. The ability to measure extreme redshifts is what sets James Webb apart, allowing astronomers to peer into the infrared range and observe the first galaxies in the universe. Excitement is palpable, as this discovery marks an important milestone in the exploration of the universe and in understanding its evolution. The discovery has had a major impact on our understanding of the universe and has prompted NASA to develop even more powerful telescopes than the James Webb Space Telescope, to confirm whether our understanding of the Big Bang is correct. Data obtained from Webb's F spectrometer and near-infrared camera have revealed that 4 of the 6 primordial galaxies have extreme redshifts, suggesting that Webb is observing these galaxies as they were shortly after the dawn of the universe, likely within 300 million years of the Big Bang. This pushes the boundaries of what scientists previously believed was possible and opens up new questions about how galaxies formed so quickly in the early universe. These findings also challenge our current models of cosmic evolution. According to standard cosmological theories, such massive and mature galaxies shouldn't exist so soon after the Big Bang. Yet, the Webb telescope has captured clear spectral data proving not only their existence but also their complexity. Some of these galaxies contain surprisingly high amounts of stars, dust, and even elements heavier than hydrogen and helium, which are usually formed later in the life cycle of stars. The presence of such elements raises intriguing possibilities. Were there earlier generations of stars that lived and died even faster than we expected? Or are our current models of star formation and galactic evolution fundamentally flawed? Researchers are now revisiting their models and simulations, incorporating this new data. The hope is that with better computational methods and future observations from both Webb and other next-generation observatories, we'll be able to refine our understanding of how the early universe evolved. Meanwhile, the global scientific community is buzzing. Collaborative teams from NASA, ESA, and institutions around the world are pooling their findings, trying to piece together a clearer timeline of the universe's infancy. Papers are being published rapidly, conferences are being organized, and students and researchers alike are entering what many are calling a golden age of observational cosmology. Looking forward, NASA plans to complement the Webb telescope's capabilities with future missions like the Nancy Grace Roman Space Telescope, scheduled for launch later in the decade. This telescope will further explore dark energy, dark matter, and the structure and evolution of the universe, areas that have only grown more mysterious in light of Webb's discoveries. Ultimately, the James Webb Space Telescope has not only fulfilled its mission to look deeper into the cosmos than ever before, it has fundamentally altered our place in the cosmic timeline. As we gaze into the depths of space, we are, in a very real sense, also looking into the roots of our own existence. And with every photon it captures, Webb is writing a new chapter in the story of the universe, one we are just beginning to understand. Them as if they existed 300 to 500 million years after the Big Bang, without heavy elements such as carbon. This is surprising, since the universe is estimated to be 13.8 billion years old, and the existence of these galaxies suggests that we need to revise our understanding of the early universe. This has generated concern in the scientific community. In light of these new discoveries, they challenge the current cosmological inflation model and the Big Bang theory, which has some loopholes, such as going against the thermodynamic principle and not having a clear explanation of what caused the Big Bang. In addition, the James Webb Space Telescope is discovering galaxies almost as old as the Big Bang itself, which questions everything that we thought we knew about the origin of the universe. According to theoretical physicist Michio Kaku, the discovery of ancient galaxies by the James Webb Space Telescope has called into question everything we knew about the beginning of the universe. Previously, these galaxies were thought to be less developed than the Milky Way, but the new findings suggest that we may be missing crucial information. The fact that 6 galaxies have been found using a telescope that existed just 500 million years after the Big Bang, and are up to 10 times greater than the Milky Way raises the question of whether our current theories about the creation of the universe are correct. Kaku explained that it takes billions of years to create a galaxy like the Milky Way, so it is strange to find such large, young, primordial galaxies. This discovery may require us to revise and rewrite the textbooks about the beginning of the universe. Findings from the James Webb Space Telescope challenge what we thought we knew about the Big Bang, leaving scientists at a crossroads. Despite this, NASA recently tweeted about a galaxy cluster that lies just 650 million years after the Big Bang, adding another intriguing piece to the puzzle. Astronomers have analyzed the data and concluded that this fledgling cluster is expected to grow in size and become something similar to the colossal Coma A1656 cluster. The place where all this is taking place is unique and special, as it is in an area of accelerating galactic evolution. Thanks to the James Webb Space Telescope, researchers can now measure the velocities of these 7 galaxies, which gives them the confidence to confirm that they are bound together in a protocluster. To put this in perspective, NASA scientists compared these distant galaxies to small drops of water in different rivers that will eventually join together to form a large, powerful river. Clearly, what we formerly believed about the Big Bang is not adding up as expected. However, more data from the Webb telescope may reveal evidence that could confirm or disprove the theory. Who knows, maybe the Big Bang did happen, but what caused it is a different story. In any case, we must wait for additional discoveries. But the answer may be closer than we think. What do you think about these discoveries? Share your thoughts in the comments box, and I'll see you in the next video. Thank you so much for watching. As the James Webb Space Telescope continues to peer deeper into the cosmos, it's not just providing answers, it's raising even more profound questions. Every image it sends back challenges long-held assumptions about cosmic timelines, structure formation, and the very sequence of events that shaped our universe. Some scientists are now suggesting that we may need a new framework altogether, one that goes beyond the Big Bang and incorporates variables we have yet to define or understand. Could it be that the universe didn't begin with a singular explosion, but rather emerged from a series of overlapping quantum events or multidimensional interactions? The possibility is both thrilling and unsettling. Furthermore, the telescope's ability to detect infrared light from the earliest stars and galaxies allows researchers to analyze the chemical compositions, temperatures, and even the motion of celestial bodies from the dawn of time. These insights could eventually reveal whether our universe is unique, or just one of many in a vast multiverse. As this paradigm shift unfolds, one thing is clear: we are standing on the edge of a scientific revolution. Just as Galileo's telescope shattered the idea that Earth was the center of the universe, the James Webb Space Telescope might soon reshape our understanding of where, and how, it all began. Stay tuned as we continue to explore these monumental discoveries. The universe is speaking. We just have to listen.